Welcome back to Code Wonka channel. Today we will be solving lead code problem 71, simplify path. Let's go over the question. You are given an absolute path for a Unix file system, which always begins with a slash. Your task is to transform this absolute path into its simplified canonical path. The rules of a Unix file system are as follows. A single period represents the current directory. A double period represents the previous or parent directory. Multiple slashes such as consecutive double slashes, consecutive triple slashes are treated as a single slash. Any sequence of periods that does not match the rules above should be treated as a valid directory or file name. For example, 3 periods, 4 consecutive periods are valid directory or file names. Let's understand the question using this example test case where path is this and output is this. Let's understand what canonical path is. A canonical path is always an absolute path which starts from the root directory of the file system. To transform the input path to a canonical path, we need to apply some redundancy elimination rules on the input path. Those are current directory rule. References to a single period are resolved to the current directory by eliminating the single period. Parent directory rule. References to double periods are resolved to parent directory by eliminating the current directory and double periods. Multiple separators rule. Consecutive directory separators, example double slashes, are reduced to a single separator. Let's try to follow elimination rules on input path variable by starting with looking at single period characters. This is an occurrence of the single period character, and according to the current directory rule, we eliminate the single period. Let's look at double period characters to follow the parent directory rule. These are the two occurrences. According to the rule, it resolves to the parent directory, which for the first occurrence is directory FB and for second occurrence is directory B. The current directory and the double dots are eliminated. This rule gives you a hint to use stack because when certain condition is met and based on that we have to take few steps back, then stack is a useful candidate for that. Essentially, we are trying to backtrack from current directory to the parent directory. And for backtracking algorithms, stack is a good candidate to use. Other options would be recursion or dynamic programming. We'll see in solution visualization how stack is helpful. Let's look at multiple separators rule. These are the occurrences of 3 consecutive separators. This gets reduced to a single separator. So let's eliminate the 2 of the 3. After removing the eliminated characters, the string looks like this. Still, the multiple separators elimination rule applies on the string. We reduce these consecutive separators to a single separator. After removing the eliminated characters, the string looks like this, which equals to the expected output. After understanding the question better, we get this intuition that we need to traverse all the characters in the string and then apply the elimination rules. If we encounter a single dot, then we ignore it. If we encounter a double dot, then we go to one directory up. If we encounter consecutive slashes, then we resolve them in a single slash. Let's look at the solution visualization. We will split the string based on slash to create a path list array. This operation also executes the multiple separator rule as all the occurrences of the consecutive slashes will be eliminated. Next, we initialize the stack to empty. We will begin the sequential traversal of elements in path list starting from the first element. The directory name FP does not satisfy the 3 condition, so we append it to the stack. Directory A does not satisfy the 3 conditions, so we append it to the stack. Double period satisfies the parent directory rule. We need to go to the parent directory of current directory A. The parent directory is FB. We do this by popping the current directory from the stack. We append directory B to the stack. We append directory C to the stack. We found double period, so we need to go to the parent directory B. To do this, we need to eliminate current directory C. We do this by popping it from the stack. We append directory D to the stack. This is empty string element coming from splitting consecutive slashes with slash in input path variable. We do no operation when we find empty string element. This is again empty string element coming from consecutive slashes here in the input path variable. We do no operation. Now we found a single period which satisfies the current directory rule. It refers to the current directory D, which is already in the stack, so we do no operation and move to the next character. We append directory E to the stack. Next we convert the stack in string by joining it with slash character, and we get the expected output. Let's look at the code of the solution. We split the input path by slash to convert it into path list array. We initialize the stack to empty array. Then we write a for loop to traverse directories in path list array. If the path has double period, then we eliminate current directory from the stack to go to the parent directory. If path is empty or has single period, then we do no operation and continue. Else, none of the elimination conditions are met, then we simply append the current directory to the stack. At the end, we convert the stack to a string by joining the stack elements with slash character and return it. The time complexity of this code is O of n because of split operation and for loop used to get the canonical path. Here n is the number of characters in the string. The space complexity is O of n because of the storage used by the stack and the path list variable. Please leave your feedback in the comment section. If the video helped in learning, then like, subscribe and share. Thank you for watching this video and stay tuned.